Hello, in this video we are going to be graphing the sine and cosine functions. So we're going to be looking at the characteristics of the sine and cosine functions. We're going to stretch and shrink the graphs of sine and cosine. We're going to translate them up down. We're also going to translate them left right. And we're going to reflect the graphs of sine and cosine functions. Okay, so you may be asking, how do we graph sine and cosine? Well, think about it this way. When you have a unit circle, right, where this point right here is the point 1, 0, you'll remember from your previous lesson that 1, this first x value, is the value of cosine of that angle theta. So that's what your x value represents. And then your y value represents the value of sine of that angle. And as we move our angle around our unit circle, this x value decreases, right? And the y value increases. Okay, if we move it even more around to here, we now have the point 0, 1, right? So cosine of that angle has decreased all the way to 0, and sine has increased all the way to 1. We can keep rotating and rotating some more so that we get back to this x value is -1, so that's your cosine of theta, and the y value is 0, so that's your sine of theta. If we rotate some more, we can rotate around here, and we get this point right here. So that point right there is the x value is 0, that's your cosine of theta, and the y value is -1. That's the sine of theta. And if we keep going around the circle, you'll notice that we get back here and we start all over again. So we're going to repeat the same pattern, get back to the beginning and start all over again. Repeat the same pattern, right? So there's a lot of patterns going on in the x and y values of our circle. Okay, so if we want to graph the function that is known as y equals sine of x, that's going to be our parent function. Okay, y equals sine of x. We could use a calculator and crunch some numbers and fill in all of these values, right? If x is -2 pi, we're going to find the sine of -2 pi and fill in those values here. Okay, but really what most people are concerned with is actually just the first little portion starting here when x is 0 and ending here when x is 2 pi. Okay, so if we go to x is 0, that's this point right here, and keep going to x is 2 pi and fill in all of these with their corresponding y values, okay, you will notice that when x is 0, you plug that into your calculator, the sine of 0 radians is 0, okay? The sine of pi over 4 radians is going to be 0.7071. The sine of pi over 2 is going to be 1. The sine of 3 pi over 4 is going to be 0.7071. The sine of pi is going to be 0. The sine of 5 pi over 4 is going to be -0.7071. And you may notice a pattern already. The sine of 3 pi over 2 is going to be -1. The sine of 7 pi over 4 is going to be -0.7071. The sine of 2 pi is going to be back to 0, right? So we can take all of these that are zeros and -1s. Those are super easy to plot. We can plot a point at 0. When x is pi, we've got another point at 0. When x is 2 pi, we've got another point at 0, right? We call that our midline, right? The reason we call it our midline is going to be clear in just a second. When x is pi over 2, we go up and we have a maximum point of 1. When x is 3 pi over 2, we go down and we have a minimum point of -1. Okay, and we could fill those in. We could fill in the rest of these decimal points. They're a little bit hard to approximate, right? But basically what you're going to get is this curve, right? And a computer can do a much better job than me. This is what we call one cycle, okay? That is one complete cycle. We could take this and make a stamp out of it and just stamp, 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 repeat all the way across, and we're going to get a very nice repeating wave. From 0 to 2 pi is one period. That's how long it takes to get from the beginning to the end of one cycle, okay? So I have plotted those points right here, right? Much, much nicer. We're starting at the midline, going up, midline, down, midline. That's one cycle. If we take that and we repeat it, we're going to get this, right? So we've got a cycle, another cycle, and then we would keep going, right? So we could trace that. Up, middle, down, middle, up, middle, down, middle, up, and we would keep going, and that would be very repetitive. It would be very pretty, actually. Okay, we can do the same thing with cosine. So if y equals the cosine of x, we can also fill in the table with cosine. Okay, cosine is a little bit different from sine in that it doesn't actually start at 0, because you'll remember on our unit circle, right? That's a bad sketch of a unit circle, but you get the idea. This point right here is going to be 1, 0, right? 0 is where sine starts. 1 is where cosine starts. So cosine, when your angle is 0, cosine starts at 1 and then goes with the same pattern, right? So cosine starts at 1, goes with the same pattern of 0.701 or 71, and then 0, and then negative 0.7071, and then -1, negative 0.7071, 0.7071, and back up to 1. And that is going to complete one cycle for you, okay? So you can see that I've plotted the dots for one cycle right here, right? Starting with your angle is 0, going all the way to an angle of 2 pi, so completely around the circle exactly once. We start up high, middle, bottom, middle, top, okay? And that's going to be one cycle, right? That has a period length of 2 pi. From 0 to 2 pi is how long it takes to complete that cycle. And if we take that cycle and repeat it, okay, and fill in the rest of the values, you can see our wave starting high, middle, bottom, middle, top, middle, bottom, middle, top. We'd go back down to the middle, and we would keep going. And this would be a very lovely wave, a very lovely pattern. Okay, so now that you're familiar with the patterns of the waves for sine and cosine, let's talk about how to transform the function, to change the way that it looks. It's still going to be very repetitive where you have a top, middle, bottom, middle, top, okay? But we're going to stretch it taller. We're going to shrink it from left to right so that the whole wave happens faster. We're going to move it around. Okay, so if you would, you might want to take a moment to pause the video so that you can copy down these. These are the notes, right? And then I have a few examples after this, okay? We have y equals a times the sine of b x minus h, and that's all in parentheses, right? This whole thing right here is in parentheses, and then plus k. You can swap out the sine for cosine, and all of these a's, b's, h's, and k, they do the same thing. They actually do the same thing that they have been doing in all of the other functions that we've been dealing with, right? So this number in front, that's a multiplier. that number in front, the multiplier, is going to stretch the graph taller, right? It's going to stretch it. If that number is a negative, it's going to flip it over the x-axis, okay? This multiplier on the inside, right, after sine, you've got parentheses b. That multiplier on the inside b is going to shrink it from left to right. It's like you're squeezing the sides of it, right? It's going to make it so that you can fit b number of waves within that 0 to 2 pi original period length. So in other words, one period is going to be 2 pi divided by the absolute value of b in how long it is, in its length. Okay, next we've got this h right here, minus h on both of them. That's going to do the same thing. It's going to shift it left or right. If you are subtracting a number, you shift right. If you are adding a number, you shift left, because remember, adding a number, really what you're doing is you're doing x minus negative h, and that negative h is what shifts it to the left. Okay, and then finally, if you want to shift your wave up or down off of what we call the midline, that's the middle of the graph, top, middle, bottom, middle, you've got the middle, that's the midline. Plus k will shift that midline up, and minus k will shift that midline down. Okay, so let's do a couple of examples together to see how that's actually working. First, example 1, we want to graph a sine function. Okay, so I have the parent sine function already done on this graph. What we want to do is we want to graph g of x equals 4 times the sine of x. 4 right there is specifically going to change what we call the amplitude. So the amplitude is 4. That means from the midline, you're going to stretch the top and the bottom 4 times farther away, right? So from this midline right here, you're going to stretch the top of it. Instead of going up to 1, it's going to go up to 1, 2, 3, 4. That's going to be the top of your graph. From the midline, the bottom of your graph, instead of going down to -1, it's going to go down 2, 3, 4. So our amplitude of 4 is stretching the high points and the low points. It's not changing where your x-intercepts are, because we haven't done anything else to the graph. So instead of having a point right here, we're going to have the high point up at 4. In the middle, instead of a low point at -1, we have a low point at -4, and then back to the middle. Okay, so our function, now make sure that you're drawing these nice and smooth. We don't have a pointy top, we have a rounded top. Down through the middle, round at the bottom, through the middle, round the top, through the middle, round the bottom, through the middle, and you get how this would just keep going, right? You could have on the negative side of your x-axis a low point of -4, middle, a high point of +4, middle, and you would again repeat that. Go down, round the bottom, up through the middle, round the top, down through the middle, and that would keep going. That pattern would just repeat itself over and over and over again. Okay, for this example, we want to graph g of x equals 1/2 of the cosine of 2x. So I have the parent function already graphed in blue, so that's going to be our guide, right? This 1/2 means that the amplitude is only 1/2. So instead of going all the way up to 1, we're only going up to a half. Instead of going down to -1, we're only going to go down to -1/2. Okay, but then you'll notice we have also changed b right here, right? So the period is going to be 2 pi, divide that by 2. So the period happens in just pi units. So from 0 to pi, you go from the top to the middle, to the bottom, to the middle, to the top, all within just from 0 to pi. okay? So I like to plot the beginning and the end, and then halfway between those, I know I've got a low point, except those aren't my points. I need to change my amplitude. So the beginning of this is going to be at 1/2. The end of it is going to again be at 1/2. The low point is going to be in the middle, -1/2. And then halfway between the high point and the low point, I'm going to hit 0. Halfway between the low point and the high point, I'm going to hit 0, right? And then I can repeat that pattern, right? Middle, low point, middle, high point, middle, low point. I could repeat that pattern on the other side, on the negative part of the x-axis. Middle, low point, middle, high point, middle, low point, middle, high point. Okay, and then we can graph that, and we just make a nice smooth rounded at the top, through the middle, rounded at the bottom, middle, round the top, middle, round the bottom, middle, round the top, middle, and the bottom, middle. You get the repetitiveness? I mean, after a while, this almost becomes so easy that it's almost boring, right? Middle, round at the top, middle, round at the bottom, and then from here it would keep going up, right? From here, the left end, it would keep going down, and it would just keep repeating over and over and over. So you can see very clearly that what used to be from 0 to 2 pi, that having one cycle repeat, we now have 1 and then 2 cycles to match this 2x, right? Okay, let's try this example without a parent function to help us get started. So this time we have graph g of x equals 2 times the sine of x and then plus 3. Okay, so if you'll remember our parent function, sine of x starts in the middle, ends in the middle, halfway is in the middle. Okay, from the middle, from the midline, we have a high point, midline, low point, and that's our parent function. Okay, this 2 in the front is going to be the amplitude, right? So that's going to make our graph stretch 2 times farther away from our midline. But before we can get there, we actually need to plot our midline of plus 3. So we're going to move the midline up 3 units. So here's 0, 1, 2, 3, right? Our midline is going to be moved up 3 units, okay? And then from there, our amplitude of 2, we have beginning at the midline, ending at the midline, halfway between those, hitting the midline again. Halfway between those, we're hitting our maximum. It's an amplitude of 2. So from the midline, count up 2 units. Halfway between the center point and the end point of one cycle, we're hitting the low point, but the amplitude is 2, so our low point goes down 2. Okay, and that's going to be one complete cycle. Okay, we can repeat that and complete the rest of it, right? Just by repeating this cycle. So we're going to go up, middle on this side. We're going to go down, middle, up, middle, down, middle. We'll just fill up the graph if we can. Oops, that's a little bit on the V-shaped side. Let's fix that. We want a rounded, not a pointy. Round the top, down through the middle, round the bottom, up and catch the rest of that graph and keep going. Okay, that looks beautiful. All right, and then this one, we have an amplitude of 5. So this is going to be a very tall graph. We have a horizontal shrink, right? So we have a shrink the period, or stretch the period actually. So we're going to do 2 pi, divide that by 1/2. But if I really think about that, 2 pi divided by 1/2, I need to switch my fraction around. So it's 2 pi times 2, okay, which is going to be 4 pi. So 1 period is going to happen from 0 to 4 pi, right? So from 0 all the way to 4 pi. That's going to be 1 period length, okay? But wait, there's more. We have this minus 3 pi. That means that we are shifting the whole entire thing to the right by 3 pi units, right? So instead of here, we've got 2 pi. So here must be 1 pi, 2 pi, 3 pi. So that's actually the start of my cycle. From here, 1 pi, 2 pi, 3 pi, and that's actually the end of my cycle, right? So this is my primary cycle that I could make a stamp out of and repeat. Starting here, ending here. You'll notice that this is a cosine function, so it starts high, middle, bottom, middle, high, okay, with an amplitude of 5. So from here, it's going to start 1, 2, 3, 4, 5, and it's going to end at 5. Halfway between those, we're going to hit our low point, our bottom, right? So we're going to have down here, -5, that's our low point, that's our minimum. Halfway between the max and the minimum, we're going to hit 0. Halfway between the minimum and the max, we're going to hit 0. And then we graph a nice smooth rounded curve through that. And that's one cycle, okay? If I want to repeat that, I can. I would go to the middle, to the bottom, to the middle, to the top. On the right side, I would go to the middle, and now I'm out of room. So I would just draw this curve and then finish this curve here. This is a little pointy for me. I'm going to make that more rounded. Okay. And then, of course, this would come back down and this would continue, right? So that is how you graph that one. Thank you for watching. If you don't have a graphing calculator at home, keep in mind on your Chromebook or on any computer or even on a regular cell phone, you can go to desmos.com/calculator. You can even download a Desmos app that will help you graph on your phone if you need to. Okay, and when I put this into a PDF form, you'll be able to click that globe right there. It should be active for you.